Janet lives in a crowded downtown neighborhood in a big city. She loves her downtown, but there are too many paved roads and no parks. Here's a map. These are the roads, and these are the blocks full of buildings. Janet decides to fight for more parks. The city can tear down old buildings and convert some blocks to parks for kids. Janet wants the area of the parkland to match the area of the paved roads. So how many blocks will need to be converted to parks to match the area of the roads? Janet needs to find the area of the roads. There are often many ways to solve composite area problems, and Janet starts by trying to find the area of the roads directly. The roads are 10 meters wide. The horizontal rectangles of the roads are 10 meters by 560 meters. We calculate the area by multiplying the width times length, so each of the horizontals has an area of 5,600 square meters. Since there are 4 of them, we multiply by 4 to get 22,400 square meters as the area for all the horizontals. The vertical rectangles are 10 by 340, so each of the verticals has an area of 3,400 square meters. Since there are 6 of them, we multiply by 6 to get 20,400 square meters as the area for all the verticals. If we add the area of the horizontals and the verticals, we get a total road area of 42,800 square meters. But there's a problem. When we added the horizontals and the verticals, we actually added the area of the intersections twice. We need to subtract the extra intersections from the total. So what's the area of the intersections? Since the roads are 10 meters wide, the intersections are 10 by 10 squares. Each intersection has an area of 100 square meters. There are 24 of them, so we subtract 2,400 to get an actual road area of 40,400 square meters. It was pretty clever of Janet to notice she needed to subtract the intersections that were counted twice. Is there another way to find the answer? Sure, Janet could calculate the area of the entire downtown and just subtract the area of the city blocks. The area of the entire downtown is width times length, or 340 times 560, which gives us 190,400 square meters. Janet knows the city blocks are 100 by 100 squares, so the area of each block is 100 times 100, or 10,000 square meters. There are 15 blocks, so the total area of the blocks is 15 times 10,000, or 150,000 square meters. The total area of the downtown, minus the area of the blocks, gives us a road area of 40,400 square meters, the same result that Janet got before. It's another clever way to solve this composite area problem. Now, how many blocks does Janet need to turn into parks? The total road area is 40,400 square meters. That's our desired park area, and each block has an area of 10,000 square meters. Dividing shows us that a little more than 4 blocks have to be turned into parks. When solving composite area problems, it's important to remember that there will be several possible approaches. In this case, our first approach was to find the area of the roads directly and subtract the intersections. Our second approach was to find the area of the downtown and subtract the city blocks. You should be creative with composite area problems and pick an approach that works best for you. Even better, pick 2 and see if you get the same result in both cases. Let's hope Janet is successful at convincing the city to turn 4 blocks into parks.